So we're talking about properties or laws of logarithm. Try that one more time. Logarithms. And what we're going to be doing is today we're going to be learning how to either take a single log and expand it into multiple logs, or take multiple logs and shrink it into one logarithm. Then we're also going to talk about the change of base formula, like how can we find the value of a log that's not base 10. Okay, so we're kind of combining two lessons in one because the change of base formula is not hard, it doesn't take long. So the first law or property of a log says we can have some log of any base, so log base b, and then in your argument you can have a product of two or more numbers. In this case I did some variables m and n, and it says that you can split those into two separate logarithms by taking each piece that you're multiplying inside and putting them as two separate logs by adding. So for example, if I had, let's put some numbers in here. If I did the log base 2 of, I don't know, 8 times 4, okay? Or technically you could write that as 32, right? What you can do is you can split this into two separate logarithms by taking the log, keeping the same base, and then you just take each part of your product. So the first one would be 8. And then you do plus the log base 2 of the second part of your product, which would be 4. Okay, so you can split those into multiple, or you can go, if they're split into multiple, you can bring them together. So if there being two logs being added, what you do is you write them as one by multiplying the arguments. And so depending on which way we're going, if we're splitting it up, you're going to have a product, you'll split it into 2 by adding. If you have two logs that are being added and you're asked to write it as a single log, then you will just take and multiply the two arguments. Okay. The second rule is if I have a quotient or two things being divided in my argument, then I can separate that out by taking and writing two separate logs and subtracting. So multiplication goes with addition and division goes with subtraction. And again, it can go either way. If I have multiple logs, I can use this rule to write them as one single log, first argument divided by second, or if I have that quotient there. So we could do something, putting in some numbers again. If I did the log base 2 of, I don't know, 1 over 3, for example, I can split this up into logs by taking the log base 2 of the top number minus the log base 2 of the bottom number. And that's how you would split it into 2. So if it's multiplying, you split it up by adding, or if it's 2 being added, you put it together by multiplying. If it's division, you can split it by subtracting, or if it's subtracting, you can write it together by dividing. I'm just trying to give an example without variables, so you can see what it looks like. All right, and then the third one looks like this. I'll give you a minute to write it down and maybe split it. So on this one we have some log with a base, and that's in my argument is m to the p power. And what this rule says is anytime I have an exponent on my argument, then I can take that exponent and I can move it to the front of the log and multiply it. So if I had the log base 2 of 3 squared, okay, what this rule says is I can take that exponent and then I can move it to the front of the log, so it would become 2 times the log base 2 of 3. Okay, just something without variables in it. So anytime your argument has an exponent on it, you can move that exponent to the front of the log and multiply it. Or if you have a number in front of the log, to make it one single log, we move it as an exponent. Everybody ready? Okay. So we're going to start by taking a single log and expanding it into multiple, I think. Yeah, okay. To make sure we're going the right direction. So we're using the laws of the logs, or the properties of logs, to expand each expression. That means I'm going to take and I am going to write it as multiple logs. If you'll just write those three down and then we'll talk about how to do them. And the reason we need to know these laws is because we're going to deal with some equations tomorrow where we have to bring them all together to be able to solve for missing parts of our log equations. So they'll be a little bit different than the equations that we did on the quiz yesterday. So I have the log base 6 of xy. So when you start deciding how to expand it, the very first thing you want to do is look at your argument. You want to decide, do I have things that are being multiplied, things that are being divided, or do I have an exponent? Which one do I have here? Multiply. So in order for me to expand this into multiple logs, because they are being multiplied, I'm going to add them. So I'm going to take log, keeping the same base. I'm going to take the first part of my product, which is x. And then I write plus the log base 6 of the second part of my product, which is y. Neither of my arguments have a product anymore, a quotient, or an exponent, so that means I am finished with expanding that one. That's exactly how we would leave our answer. On the second one, I have log base 8 of x over y. Again, I'm looking at my argument to see what I have. Do I have multiplication, division, or an exponent? Which one do I have here? Division. So we can split up division by subtraction. So what we do is we take log base 8 of the top number minus the log base 8 of the bottom number. Yeah, that's a minus. It just didn't show up the first time. And then to just make sure I'm finished, I look at the argument of each one of my logs. Neither one of them have a product, a quotient, or an exponent anymore. So I know I've expanded it as far as I can. And then the third one, I have log base 4 of x to the third. Again, I'm looking at the argument. Do I have a product? Do I have a quotient? Do I have an exponent? Exponent. So that rule says that I can then take this exponent and I can move it to the front of the log and multiply it. So it would be 3 times the log base 4 of x. You don't have to put the dot there. You could just put 3 log 4 of x. I just put the dot to make sure, show you what I'm doing. But I wanted to talk to you about this too. Let's look at this another way. What does x to the third mean? That means x by itself how many times? 3. So could I write it like that? And then because I have a product, I have 3 parts here. I can expand this out by going log base 4 of x plus log base 4 of x plus log base 4 of x, right? How many log base 4 of x's do I have? 3. So does it make sense that I could also just write it as 3 times one of these? Okay. Either one of those is okay, but it's easier to just take that exponent and move it to the front than trying to write it out like this. But they mean exactly the same thing. Is everybody good there? All right. I want you to try 4. Hold off on 5. I'm going to need to talk to you about 5, and then I'll let you try that in 6. ahead and try 4. It'll be very similar to 3. Log base 2 of x to the 1/2 power. So do I have a product, a quotient, or an exponent? Exponent. So we're going to take that rule and we're just going to move that exponent to the front. And we're just going to go 1/2 times the log base 2 of x. Now 5 is a little trickier because a lot of the times we don't think about what that means. It's the log base 6 of the square root of x. Okay, so my argument is just the square root of x. Is that a product of things? Anything being multiplied? Is it a quotient? Anything being divided? Is it an exponent? Can it be an exponent? Think about this. If we write the square root of x, what root are we taking? What power are we raising it to? So can I not write like that and it means the same thing? Okay. So anytime, especially when you are expanding, if you have a radical, a square root, a cube root, what you're going to first do is change that into an exponent. So we're going to rewrite this as the log base 6 of x to the 1/2. And then it turns into a question just like number 4. Okay, we've got to get the understanding that radicals can also be exponents. And the same is going to be when we go the other way. If I have a fractional exponent, we will write it as a radical, but we'll get to questions like that in a minute. So what I'm going to do now is take that exponent and I'm going to move it to the front and it becomes 1/2 log base 6 of x. Does that make a little bit of sense? Okay. Now I want you to try 6, but let me ask you a question. The exponent that is in my argument, is it attached to both x and y, or just x or just y? Just y. So keep that in mind when you're expanding that one out. Okay, that squared is only attached to the y. It is not attached to the x. So what you have to do is split up the product first. Then you move the exponents last. Okay, product first, then the exponents last. Just try it, see what you come up with. All right, in my argument, what two things are being multiplied? X and y squared. So what we're going to do first is we're going to go split up the product first. Not quite done though, because one of my arguments can still be expanded because it has an exponent in it. Does the first argument, the log base 7 of x, does that have anything that needs to be expanded? No, so I'm going to bring that down. And then what can I do with that 2 here? I can move it into the front, but only of that log. So it becomes 2 times log base 7 of y. It doesn't go in front of the one with the x because that squared is not attached to the x. So just be very careful with those. Make sure you know what your exponents are attached to. If I had put that x and y inside parentheses, then the 2 would go for both of them. Anybody have any questions on how to take one log and expand it into multiple? Okay. All right. So when you are expanding, you take a product, a quotient, and you split those up first. If there are any exponents, that is going to be the last thing you move in an expansion. Now, when we go the other direction, when we go from taking multiple logs and writing them into a single, the exponent is going to be what we move first. Then we'll bring stuff together with adding and subtracting. Or, I'm sorry, multiplying and dividing. Is everybody ready? Okay, take a minute, write this couple down. We'll talk about what to do here. Again, we're using these laws to now take multiple logs and put them as one. This is mostly what we will be doing tomorrow when we have our log equations that we are trying to solve. We're going to have to take multiple logs and write them as one. So when we do this, the very first thing I want you to look for is, do either of my logs have a number in front of them that needs to move as an exponent? No. Okay. Then what I'm going to look at is the operation. My 2 logs are being added. What goes with addition? Multiplication. So to write these as one, I'm going to write one. I'm going to write one log. Okay. The word log one time. I'm going to keep the same base. And then what I do is I take the arguments, the 5 and the x, and I multiply them. What is 5 times x? 5x. And that is all I do. That is my single logarithm. So we're basically just going backwards from what we just did. Okay, try the rest. Try 8, 9, and 10. We're going backwards. Again, you're looking, the very first thing you look for is, do my logs have a number in front that needs to be moved to an exponent? If so, yes, move it. If not, then you look at the operations. What am I doing? Am I adding or subtracting? So that way I know whether I'm supposed to multiply or divide. 10's going to be a little tricky. We'll talk about why once I get everybody a chance to do it. First one on top. Anytime there's a number in front, see how we have the next one here and then to the front. So to go backwards, we have a number in front. The 1 and the 8 doesn't change. Number 8, do I have a number in front of my log that needs to go as an exponent? Yes. So I'm going to take that and I'm going to put it as an exponent just on the argument. The log and the base stay the same, and that is now going to be written as x to the 6th. Do I have any other addition or subtraction that I need to get rid of? No. So that's just all I can do here. Number 9, log base 4 of x minus log base 4 of 10. Do I have any numbers in front of my logs that I need to move as exponents? No. And these two logs are being subtracted, so we're going to bring them together by dividing the arguments only. Whichever one is written first goes on top. So it's going to be log base 4 of just the argument x divided by just the other argument 10. And here's where 10 is tricky. What is my argument in number 10 as it sits right now? 3x. So when I take that 2, does that 2 go to just one part of the argument or the entire argument? The entire thing. So what we're going to do is we're going to take this and we're going to move it as an exponent, but on that whole thing. So this is how I need to write it. Log base 7 of, I'm going to show you several different ways we can write it, okay? You have to put that 3x in parentheses. Or you can give it to both the 3 and the x. And then if I do that, what would probably be the better way to write that? Instead of leaving it as 3 squared, what could I turn it into? 9. Okay. This is the most simplified form. But if you leave it like that, I'm not going to count it wrong as long as you put the parentheses around it, okay? I would prefer it to be left as 9x squared. But if you put that 3x in parentheses and put the square on the outside, I will definitely give you credit for that. You just have to know that that argument had 2 parts to it. It had a 3 and an x. So therefore that 2 in front has to go to both of them. Does that make a little bit of sense? Okay. Now, what I want to do is switch gears. If you do not have a calculator, you're going to want to grab one real quick. We're not doing this day 2 because it doesn't take long. I'm going to give you a minute to write this down and we'll talk about how can I find the value of a log when it is not base 10. Base 10 is the only thing our calculators work in. If you will write that, I will then explain it to you and it will be very easy, I promise. If you don't have a calculator, go ahead and grab one. This is a trick that we can use, or a rule that we can use anytime we're asked to find the actual numerical value of a logarithm, and it is not a base 10. Because remember I told you, calculators only work base 10 for most of us. Some of us have one that can work, but most of us have one that only works base 10. So we can use this, what we call change of base formula, to find the decimal value. Just a little side note down there says we use a equals 10 since we're trying to find a decimal value, since that's what our calculators work in. So basically what it says, for any logarithmic bases a and b and any positive number m, the change of base formula says this, and it looks confusing because there's a lot of variables in it. But if you'll notice right here, you have log base b of m. What we do, again, is we're changing it to base 10 for our calculators. I put an a in there. We're going to use 10 for a. But you take the log of the argument. In this case, what letter is the argument in the highlighted log? M, right? M's the argument. So you take the log of the argument, log base a of m. That's what goes on top. And you divide it by the log of the base. Okay, so you have log base b of m. You're going to take the log of m, and again, it's going to be a base 10, so I'm not even going to write that in there, divided by the log of the base. So, for example, if I were to put some numbers to that, let's say log base 5 of 7. Which one of those is my argument here? 5 or 7, which one's my argument? 7. So what we would do is we would do the log of 7 divided by the log of, what is my base? 5. And we would enter that into the calculator. Okay, it's really that simple. You do the log of the argument divided by the log of the base. We're using base 10 here for these so that we can get a decimal value in our calculators. There's just a trick we have to make sure we do in our calculators, and I'll talk to you about that in just a second. So again, it is the log, of the argument divided by the log of the base. We ready? Okay, let's see an actual example. It's telling us to use the change of base formula and to round to 4 decimal places. So if you take a minute and write that first question down, I'll work through it with you, and then I'll let you do this last 3. So if I'm trying to find the value of the log base 4 of 17, okay, and I have a calculator that doesn't do any kind of base but base 10, which one of those numbers is my argument, 4 or 17? 17. So what we're going to do is we're going to do the log of 17 divided by the log of which one is my base? 4. Okay. Now here's where you have to be careful. Hit log in your calculator. Most of the calculators open a parenthesis, right? And when we were doing it the other day, we were just finding the value of 1 log, so we didn't have to worry about closing that parenthesis. So when I enter this, I need to make sure that when I hit log and I type in 17, I have to close my parenthesis before I can do the rest of it, okay? Otherwise, it's going to be the log of 17 divided by whatever, instead of the log of 17 divided by the log, okay? So once you close that parenthesis, then you can hit your division bar, and then you can do the log of 4. The last log doesn't matter if you close the parenthesis or not because there's nothing behind it. What does matter is if you close the parenthesis on the first one. So we're going to round this to 4 decimal places. So I got 2.0437. If you did not get that value, it's because you entered something into the calculator incorrectly. Let me know so I can look at your calculator and see what you did. If you got that value, then go ahead and do 2, 3, and 4. Last ones. Use your change of base formula. We can now do it with a calculator instead of having to do what we did on the quiz. Just make sure when you're entering it, you close.
Yeah.
Make sure you close that parenthesis behind that first log. Log of the argument, log of this. All right, on number 2, what is my argument? 7 or 34? 34. So we're going to do the log of 34 divided by the log of the base. So log of 37, close my parenthesis, divided by the log of 7 to 4 decimal places is going to give me 1.8556. Is that what everybody else got? Yeah? No? No, I hit the wrong numbers. My bad. I hit 37 instead of 34. Let me try that one more time. Y'all are all looking at me like, no, I didn't get that. This time I got 1.8122. Okay. All right. That's what happens when I do the wrong number. All right. Log of, what is my argument number 3? 22 divided by the log of 4. 2.2297. Okay. And then what is my argument for number 4? Yep. So we'll do the log of 104 divided by the log of 5. And I get 2.8807. 57? Okay. Any questions? Okay.